All right, these are notes number 10. They're a little bit different because I'm going to be writing it out of the book, but if you don't have your book, you can always copy this onto paper. The objective is basically the essential question, so I'm actually going to just write EQ. To graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. So we've been multiplying and factoring quadratics, and today we're going to start graphing. So it's all about quadratic graphs and their properties. And your your page should mostly be set up. Your warm up should be done from class. Here's the first thing to copy down. I want you guys to know, and on Math Excel, there is a question about this, about the different types of function. There are linear, y equals mx plus b. Notice that the x is to the first power. That's how you know, oops, that's how you know it's linear. Oh my gosh. And then the graph of it would be a line. Then we've got quadratic, which is what we've been dealing with. X to the second power. Y equals ax squared plus bx plus c. The main part is right here that you have ax squared. When we graph, and we will be graphing today, the graphs will be a parabola shape, basically a U shape. It could be an upside down U or a U opening upward like a normal U shape. Then the other kind is exponential. There's more types of functions than this, just so you know, but for the Math Excel, it's going to ask you about these three types. Exponential has x in your exponent. It would be a slowly and then all of a sudden rapidly increasing graph. If you've ever heard something increasing exponentially, that's what it means. It seems to start off slow and then all of a sudden it skyrockets upward. Or it could have exponential decay and be going downward all of a sudden rapidly. So again, the difference between the three, linear has x to the first power, and you could have an m and a b, maybe no b, it could be 0. For quadratic, the main thing is it has an x to the second power. So that's what you're going to be looking for. I'll actually just highlight that so you guys see it real quick. Linear, the key thing there is it's x to the first power. Quadratic is x to the second power. But then for exponential, I don't know how this is going to look, but it is x. Oh, it works out. X is the exponent. That's how you know the difference, by looking at the equations of those different functions. All right, so it is important to have a highlighter as we go through this, and also a pencil and maybe even a calculator. So I would recommend you go back and look through this a bit more to try to get a better understanding. But basically, a quadratic function is a type of nonlinear function. So it's not a line, a nonlinear function that models certain situations where a rate of change is not constant. The graph of a quadratic function is symmetric, a symmetric curve with the highest or lowest point, that's going to be very important, corresponding to a maximum or minimum value. And then, like we were saying, it's the y equals ax squared plus bx plus c. And a cannot equal 0. It has to have, a can either be like an invisible 1 or any other number, positive, negative. It could be a fraction. And again, that's called standard form when it's written out like this. All right, here's some examples of what it could look like for the equation. Notice that it always has x squared, x squared, x squared. It could have another value with the x or not. It just depends. Right here it says the simplest quadratic function is also called the quadratic parent function. F of x equals x squared, or it could be y equals x squared. So we interchange f of x and y all the time. So just get used to it. It means exactly the same thing. So anyways, this is the parent function where y equals x squared. Notice that the vertex is at 0, 0. We also call that point the origin. That's why it has like a weird O. So the origin is 0, 0, where x is 0 and where y is 0. It's called a parabola. So I said that word earlier, but here it is, parabola. A parabola is a U-shaped graph. Oh, one more thing is it's really interesting. No matter what the parabola looks like, if it's pointing downward or if it's moved and shifted around or if it's skinnier or if it's fatter, It has an axis of symmetry, or we also call it a line of symmetry. It's like you can fold it so that the two sides match exactly, and it's called symmetry. The fold or line that divides the parabola into two matching halves is called the axis of symmetry. So it basically is a vertical line that goes straight down through the vertex. The vertex is the lowest point, or if it's flipped around, it's the highest point. So this is the axis of symmetry, or line of symmetry. That's normally what we call it. Oops, you couldn't see that part. Okay, there. All right, so we're gonna get going now to the next page. If you need to finish anything here, then just pause. Otherwise, here we go. Here's some other important information. And again, you might have to review this on your own a couple times to really understand if this is new to you. This is page 708, just the next page over. It says the highest or lowest point of a parabola is its vertex. That's what I was just showing you. It's highest or lowest depending on which way the parabola is going. It's high, or I'll do lowest first. It's lowest if your parabola looks like that. I'll use a different color to show it. It's the highest if your parabola shape looks like this. So it would be, this is the vertex. Either the highest point, or on this one, the lowest point. That's what the vertex is. You'll have some questions on MathXL about identifying the vertex and telling if it's a maximum or a minimum. So here it's the highest point, it's a maximum, and here it is a minimum. It's just a nice little visual to show you. So if A is greater than 0, so if A is positive, then it opens upward. That's this kind. And it's a minimum, just like what I was saying. And here, if A is less than 0, it would mean it's negative. So it'd be like a negative x squared, just so you guys understand what that means. It would look like this, and the vertex would then be the highest point. So again, we're looking at the vertex right there, or the vertex right there. And again, the line of symmetry goes straight up and down through the vertex, and you could imagine just folding it in half right there. All right, so these first problems are identifying a vertex. So, oh, sorry, if you need to pause, get that. Otherwise, we're moving on. It says, what is the vertex of the graph at the right? Is it a max or a minimum or a maximum? So the way you identify the vertex is you want to see right exactly when it's kind of like flat, when it stops increasing and decreasing. So it's this point. Remember when you write an ordered pair, it goes x first and then y, and your x-axis is side to side, and your y-axis is up and down. So my x value going side to side is -2, and my y value is up and down, it's -3. So again, you always write your ordered pair, x first and then y. So -2, -3. And it is a minimum. It's a minimum because it looks like this one over here. Sorry, right there. It's the same shape as that. It's the lowest point. I always just think it's the lowest point on the graph. Nothing's going to go below it. Minimum. So I would just write for my answer -2, -3 is the vertex. And it's the minimum. All right, so finish copying that. I want you to try number 1. When you are going to take pictures of this to turn it in to Google Classroom, make sure that you have number 1 done. You need to have the vertex and tell if it's a min or max. So you would have to do vertex, and then is it a minimum or maximum? All right, but I'm going to help you guys out with number 2 because this is a little bit different. So you can imagine if you graphed these points in the table, x is going side to side. You can just look at this graph to think 0, 1, 2, 3, 4. So from 0, 1, 2, 3, 4. The y values are starting up at 8, 8, and then 2, and then 0, and then 2 again, and then 8. So it definitely has that kind of a shape. And that point where it's like 8, and then 2, and then 0, and then 2, and then 8. It kind of goes back up again. That's kind of how I see this. That's how I read the table, as it's going side to side for the x's, It's going, starting at 8, it would be 0, and then at the 2, it's 1, and then 3. Oh, 2. I can't count. 0, 1, 2, and then 3, 4. So you can tell it's right here. That's the point where it's symmetric on each side. See how it goes 2, 8, 2, 8? So that would be the vertex. X first, so 2, comma 0. And I kind of sketched it already, but another way you could tell is because both ends are going upwards. It's going 2, 8 and up, and then 2, 8 and up. So this is your minimum. That's your minimum value. All right, so that's how you do those types of problems. There are maybe 2 on MathXL that you'll do like that. Pause if you need to. Otherwise, I'm going to the next page, which is the last page that we'll do, I think, for today at least. So it says you can use the fact that a parabola is symmetric to graph it quickly. Use that symmetry to graph quickly. First, find the coordinates of the vertex. So if you can find that vertex point, and then if you find some points on one side, that's what it's saying, points on one side of the vertex, then reflect the points across the axis of symmetry. So if I know it's like over 1, up 2, I know over here, I just do the opposite. Over 1 that way, but still up 2. And then if that's over 1 more, up 2 more, then I can just copy it. So you can use there. So you can use symmetry. And this doesn't look good because I didn't have a graph, but there. So that's what it's saying. If you can get one side, you reflect the points over across that axis of symmetry. It says for graphs of the form y equals ax squared, the vertex is at the origin. The origin is again 0, 0. And then for the axis of symmetry is the y-axis or x equals 0. So it's just like what I was showing. It goes straight through the vertex. So it says graph the function y equals negative 3x squared. It's also asking about domain and range. I'll explain that real quick as we go. So this is of the form y equals ax squared. Then the vertex is at 0, 0. So I know that my vertex is at 0, 0. So when I do my XY chart, I want to make sure I include 0. And I always include some negative, oops, I meant to write a 1. I always include some negative values and positive values. So I would go -1, -2, +1, +2. That's a good way to start. And then once you start graphing, you can see how it's looking. So I know it's probably been a while since you guys have graphed. I know we haven't graphed like at all first semester in Math 2. So remember, there's several different ways to graph. Today, we're going to be using an XY table and plugging in values into the equation. So I would be using y equals -3 times x squared, and I plug in -2 for x, and then I square it. And then I have to solve it. Then to find the point for -1, I substitute in -1, work it out. I'm going to switch to a pencil just so that it fits better. So when I work this out, I have to follow order of operations. I do -2 squared, and you can always use a calculator, but these ones are not too bad. So I do -2 squared, which is 4, and then 4 times -3, which is -12. And then I can write that in my table. Then I'm going to do my next point for y. I'm going to plug in -1, or no, not for y, but for x. So I'm going to do y equals -3. So I always use that same equation times x squared. X is now -1 squared. Let me switch to pencil just so that it fits better. So everything else stays the same, but I'm going to go ahead and do my -1 squared. -1 times -1 is +1, and then multiply that, and I get -3. So those are 2 points I have so far. Now I'm going to plug in 0. I already know what it is, but I'm going to just show you guys why it works. So y equals -3 times 0 squared. Well, 0 squared is 0. 0 times 0 is 0. And then -3 times 0 is 0. So this is the vertex. So I'm just going to show that it's special. Remember how I was saying the vertex would be 0, 0? And it is based on the solving, plugging in points and solving. And y equals, my next point is 1. So -3 times 1 squared. 1 squared is 1. 1 times -3 is -3. So I'm going to just write -3. Notice how we're getting symmetry, meaning that I'm getting the same points. Y equals -3, plug in 2 now for x, 2 squared. 2 squared is 4. -3 times 4 is -12. So you should always get this symmetry in your xy table when you're graphing quadratics. So when it's going to be like a parabola. So anyways, let's go ahead and graph that. So you just have to plot the points. 1, 2, 3, 4, 5. So yeah, I'm not going to be able to fit to -12. I am going to count by twos. That might help a little bit. So, and you can count by twos on the y-axis and just count by ones on the x. You just have to show that you're counting by twos. So if I count by -2, -4, -6, -8, -10, I just have to pretend there's one more line under here, and that would be -12. So x -2, y -12. On my x, I go to -2, then down to -12. Put a point. And then my next point is -1, -3. So since I made it counting by twos, 3 is going to have to be in between -2 and -4. So -1 is right here. And then it's going to go right between 2 and 4. Right there. And then 0, 0 is the vertex. And then you'll see that there is symmetry as I plot the next 2 points. So my next point is 1 and then -3. 1 right here. I already know where -3 is because I just figured that out. And then my next one is 2, -12. So x is 2, y is -12. And then you just connect and always draw an arrow at the end. And then curve it. It is a curve, it's not a straight line. And then an arrow at the end. So always get arrows at the ends. All right, so for domain and range, domain means what are the possible, let's make a little note, possible x values. Range is possible y values. I know this is a lot today, so we'll just keep reviewing as we go and you will get the hang of it. So whenever it asks for domain, it means, well, what values could we use for x? Well, so far I've used -2, -1, 0, 1, 2. I could keep going to the more negatives forever and ever, to negative infinity. And I could keep going to the positives forever and ever. So for domain, we actually just say all real numbers. That's what domain will always be for this chapter. So, or at least this section. Domain will be all real numbers. And then range, I just use a R for range. We have to see what values would be possible for the Y. So I can see that the arrows keep pointing down. Y values are up and down. It keeps pointing down forever and ever and ever, but it does stop at a certain point. So at this point, at 0, the Y values will never go above it. It's just going to keep going down. From here, it's just going to keep going down. So I would just write that y is greater than or equal to that point right there, which in this case, it's 0. You'll get the hang of it, but just remember domain is all real numbers. It's all the possible x values, range, y. Oh, I'm sorry, it's not greater. They have to always be less than or equal to 0. They're always going to be negative. So if you look at the y values, always negative or 0, or always negative. Y is less than or equal to 0. Okay? And that completely answered the question. So what I want you guys to do is now try that on number 3. So far on the other page, you had to do number 1. Now try it for number 3. All right, so you'll finish number 3. You know what, though? We're going to skip number 4 for now. I want to show you graphing one more type of quadratic. So if we turn the page, I want to show you, let's see, I'll show you guys right here. There's 2 quick things to make a note about. So here, okay, one more time, you guys. I just turned the page once. This is page 710. Make sure you're on the right page. So on page 710, it says the coefficient of the x squared term affects the width of the parabola as well as the direction in which it opens. So let's see, it's kind of confusing how they're explaining it. This does explain it, but what it's trying to say is that the wider, it will be a wider graph if the coefficient is bigger. That's kind of confusing. So we'll come back to this. We'll be graphing quadratics for a while, so we'll come back to that idea. This one, though, I think is pretty easy to understand. It says that the y-axis of symmetry for graphs of functions of the form y equals ax squared plus c. The y-axis is the axis of symmetry if it's like this. The value of c translates the graph up or down. So just to tell you like real quick, if the plus c is a +1, a graph, imagine this little parabola graph. Imagine that you just slide it up 1. That's all that +1 would do. If it said -1, it would slide it down 1. And it's really cool if we have a chance, we can do this. Maybe we'll do an activity later, but that's a really important thing, that this plus c moves the graph up or down. Moves up if it's positive, down if it's negative. If it's like minus a number, that's a minus. Okay, so anyways, I wanted to show you guys this real quick and make sure that plus we skipped that. I don't think it's very important. So this is way more important. We want to graph both of these. The parent function, we call it the parent function because it's very simple. It's like the most simple quadratic. It's just y equals x squared. There's nothing added, there's nothing multiplied. And then compare it to this. So let's go ahead and graph it and see what we figure out. So I'm drawing my x, or sorry, that's my y and my x axes. X is always horizontal, y is always vertical. So we always label them also. So I'll use 2 different colors. For y equals x squared, if I just do a real quick xy table, I know my vertex is at 0, 0. I want to pick -1, -2, +1, +2. So if I plug in -2, it's -2 squared, which is 4. If I plug in -1, -1 squared is +1. It has symmetry. If I plug in 1, 1 squared is 1. If I plug in 2, just to show you it's 2 squared, that would be 4. So notice that we have symmetry. I'll go ahead and graph that one real quick. So I'm going to use red for this one to just compare, okay? Oh, that's not showing up good at all. I'm sorry, guys. Oof. Okay, I'll just keep it a little dark. I'll use pen for the next one. All right, so anyways, I'm going to just count by ones. I know previously I had to count by twos. You have to make sure your graph fits. For this one, counting by ones works. So for x equals -2, +4, I count to the -2, and then I count up 4, 1, 2, 3, 4, put a point. And remember, that's just a point. The graph continues past it with that curve. And then we've got -1, 1. And then we've got our vertex 0, 0. And then we've got 1, 1, over 1, up 1. And then 2, 4. So I count from origin over 2, up 1, 2, 3, 4. And I can tell that I made them symmetric, which is how it's supposed to be. And then I just connect with a curve and arrows at the end. Connect with the curve, arrows at the end. All right. So that's that one, y equals x squared. I'm going to compare that now with y equals x squared minus 3. I'm going to do a quick little xy table. I'm going to pick the same values for x because it still has that same vertex at 0, 0. Okay, but I'm going to be plugging these numbers in now and solving. So I'll show you the work for a couple of them. I would plug in -2 for x, -2 squared minus 3. -2 squared is 4. 4 minus 3 is 1. Put that in the table. Then I do -1 squared minus 3. -1 squared is 1. 1 minus 3 is -2. When I plug in 0, it's 0 squared, but then take away 3. So 0 take away 3 is -3. And I'm doing all this in my head, but if you need to use a calculator, you can definitely do that. Plug in 1 for x, 1 squared minus 3. That would be 1 minus 3, which is -2. And then plug in 2. 2 squared minus 3. 2 squared is 4. 4 minus 3 is 1. So let me fill in that -2 and then +1. All right, so I'm going to turn the light back on so you guys can maybe see it a little bit better. I know the pencil's hard to see. So I'm just going to go ahead and graph that now with a different color. So I'm going to graph this y equals x squared minus 3, this one, with that table. So I'm looking at these points now. So I'm looking at -2, +1. So at -2, I go up 1. At -1, I go to -2 for the y right there. 0 is at -3. 1, 2, 3. And then 1 is -2. +1 for x is -2. Notice the symmetry, how it's going to be the same. It reflects across the y-axis. And then 2, 1 right there. And curve it upwards and use an arrow. You don't want to like guess past that last point. You want to just draw your arrow and continue that curve shape. So the question here is, how are the graphs related? It's like what I was telling you guys right here. Look at the vertex, or actually like the whole shape of the graph. Imagine just sliding it down. 1, 2, 3. The graph has the same shape. Everything's the same, but it has slid down 3. I would say the y equals x squared minus 3 graph slid down 3 units. That's how they're related. Okay, so I think that's about it. This video got to be a little long. We will continue practicing. Do the best you can on your Math Excel homework. Press the help button if you need help. But this at least got you a little more practice graphing. Okay, so make sure that you take pictures of this and turn it into Google Classroom under the Edpuzzle video assignment.